Something is happening in the Gulf of Mexico right now, and the water is not waiting for anyone to catch up. The surface is warm, dangerously warm, and a system is rotating out there that was not supposed to organize this quickly. Forecasters looked at the models yesterday. They looked again this morning. The numbers changed faster than expected. That is the kind of shift that makes quiet rooms go very serious, very fast. Most people hear tropical development, and they change the channel. They assume it is routine. They assume there is time. But the Gulf of Mexico is not a place that gives you time. It is one of the most efficient storm-building environments on the face of this planet. And right now, every single ingredient that fuels rapid development is sitting in place at the same time. That is not something that happens every week. That is not normal background noise of hurricane season. That is a specific, documented, dangerous alignment, and it is happening right now over open water, with a system that is already moving faster toward organization than the model suggested it would. The Gulf of Mexico is nearly enclosed on 3 sides by land. That single geographic fact changes everything about how it behaves. Because it is not an open ocean, it heats up faster. It holds that heat longer. And by the peak of hurricane season, the surface temperatures regularly climb above 30 degrees Celsius across large portions of the basin. But here's what most people do not know. The surface temperature is only part of the story. What matters even more is how deep that warm water goes. In parts of the Gulf, warm water extends 100 meters below the surface. That depth is critical because when a storm passes over the ocean, the churning action of its own winds pulls cooler water up from below. In shallower warm layers, that upwelling can cut off the storm's energy source and actually weaken it. But when the warm layer is 100 meters deep, there is no cold water to pull up. The storm feeds continuously. It does not slow down, it accelerates. Right now, the heat content in the Gulf, measured not just at the surface, but through the entire water column, is running above average. Researchers describe this kind of condition as a fast lane for intensification. A storm that rolls into this environment does not gradually build over days. It can jump intensity categories in hours. And that distinction is not a technicality. That distinction is the difference between a community having 2 days to prepare and a community having 6 hours. The system that forecasters are currently tracking started the way almost all of them do, as a disorganized mess of thunderstorms, a weak area of low pressure. The kind of atmospheric disturbance that forms many times every season and usually falls apart before it becomes anything serious. Dry air chokes it, wind shear tears it apart. The atmosphere simply does not cooperate. But sometimes, in certain locations, under certain conditions, something different happens. The disturbance finds an environment where everything that usually kills it is absent, and instead of falling apart, it starts to breathe. Wind shear is the factor that determines whether a tropical system lives or dies in its early stages. Shear is the difference in wind speed and direction between the lower atmosphere and the upper atmosphere. When shear is high, it rips the storm's structure apart. It is like trying to build a column while someone is pushing it sideways from the top. The storm cannot stack vertically, cannot build its warm core, cannot develop into anything organized. But when shear is low, the atmosphere essentially gets out of the way. The system can build upward. It can tighten its circulation. It can become a real tropical cyclone. Over the Gulf right now, shear values are low. Not absent, but low enough that it is not doing what forecasters sometimes rely on it to do, which is act as a natural brake on development. Then there is moisture. The mid-levels of the atmosphere around a developing storm need to be humid. When they are dry, air gets pulled into the circulation and starves the thunderstorm activity that drives the entire engine. Dry air entrainment is one of the most common reasons tropical systems fail to develop, even when ocean temperatures are favorable. But right now, the atmospheric moisture over the relevant part of the Gulf is above normal. The environment is not dry. It is not fighting the system. It is almost supporting it. Deep, warm water, low wind shear, above normal atmospheric moisture. All 3 of those conditions are present simultaneously over the same developing system. When forecasters see that combination, they do not look away. They update their models. They schedule reconnaissance flights. They start drafting statements, and this is where the situation becomes more urgent. What satellite imagery has shown over the last several hours is not a slow, gradual organization. The convective banding around this system, the spiral arms of thunderstorm activity that indicate a real circulation is forming, has become more defined faster than expected. The center of circulation has become more consolidated, and the cloud tops near the center, which forecasters monitor carefully in infrared satellite imagery, have gotten colder. Colder cloud tops mean taller thunderstorm towers. Taller towers near the center mean the warm core, the engine of a tropical cyclone, is trying to build. That is not a system passively sitting in a warm bathtub. That is a system actively using its environment. That is a critical difference. Rapid intensification is the phrase that carries the most weight in this field. It is defined as a wind speed increase of at least 35 kilometers per hour in a 24-hour period. In practical terms, that means a tropical storm in the morning can be a hurricane by the following morning, or worse. The Gulf's deep, warm water is precisely the environment where rapid intensification is most likely to occur. Forecasters are not declaring that this will happen, but they are saying, clearly in their data, that the environment fully supports it. In tropical meteorology, that statement carries enormous weight. For the people living along the Gulf Coast, this matters in a way that goes beyond weather statistics. Storm track forecasting has improved significantly over the last 20 years. The cone of uncertainty on forecast maps is narrower than it used to be. But intensity forecasting, predicting how strong a storm will actually be at landfall, remains far more difficult. Models regularly underestimate rapid intensification events. A storm forecast to arrive as a Category 1 can make landfall as a Category 3. That gap is not a minor forecasting error. That gap is where emergency systems get overwhelmed, where evacuations happen too late, where the human cost becomes impossible to reverse. Storm surge adds another layer to this. The deadliest component of Gulf hurricanes is almost never the wind, it is the water. Storm surge, the dome of seawater physically pushed onshore by the storm's winds and the atmospheric pressure dropped beneath it, is amplified dramatically by the Gulf's shallow northern continental shelf. Water that might pile to 2 or 3 meters in a deep water approach can stack to 5, 6, or 7 meters when it crosses that wide, flat shelf. A compact, intensifying storm hitting a shallow coastline at the right angle can produce surge that exceeds what a much larger, slower storm creates. Size is not the only variable. Speed and angle and shelf geometry all matter. And right now, none of those variables have resolved to a clear answer yet. The track forecast is still uncertain. The cone is wide, because the system is still in its early organizational phase. That uncertainty is not reassuring information. It is a call for a broader area to stay alert, rather than a smaller one to relax. The next 24 hours of satellite data and aircraft reconnaissance will sharpen that picture considerably. Reconnaissance flights measure pressure, winds, temperature, and moisture directly inside the system, data that no satellite can replicate. Whatever those flights find will drive the next round of forecasts, and those forecasts may look significantly different from what was issued yesterday. The honest truth is that the Gulf of Mexico has earned its reputation the hard way. It has taken systems that looked marginal, unremarkable, and disorganized, and turned them into emergencies within a single news cycle. The physics behind that is not mysterious. The warm water is documented. The shear data is available. The atmospheric moisture is measurable. What makes the Gulf dangerous is not that these things are hidden. It is that they can align this fast. And the window between early development and landfall threat can compress to a timeline that surprises communities even when forecasters saw it coming. What is developing right now is real. The environment is real. The potential is clearly supported by the data. Whether this system fully exploits that potential, whether it becomes a major threat or partially falls short of what the conditions allow, will become clearer in the hours ahead. But the time to start paying attention is not after the forecast is updated. The time is now, while there is still time to act on whatever comes next. Stay connected to official forecasts from your National Meteorological Service. If you are on the Gulf Coast, review what your preparedness plan looks like. The Gulf does not give long warnings when it decides to move fast, and right now it is moving. If you want to stay updated on this system as it develops, subscribe and you will not miss the next video. And tell us in the comments, which part of how the Gulf works actually surprised you most?